Good afternoon, Professor. Here I'm going to show you the first part of the development of my thesis. My name is José Originales, and the title of the work is the implementation of a disturbance observer motion controller for knee exoskeleton applications. My name is José Originales, and my thesis supervisor is Manuel Andayapa. To begin with this, you have to know that the basis or the foundations of this work are born with the mechatronics, which is a growing discipline that combines and integrates different lines of work. For example, it can be electronics, programming, and mechanics. And when we merge all of these disciplines, we create a system or a device that can be smart, that can be very useful, and can make our life way more easier. Also, you have to know that the exoskeletons, they've been working for maybe several decades, and the people have been developing different type of exoskeletons, and they have found several ways of working with them, different solutions for different problems, and different technologies for different applications. As the previous work, this is a topic that people has been working for a long time. I mean, the development of a perturbation observer control system is a known topic in the science field. Also, the creation of exoskeletons are something that people are used to hear and used to see. And so, for example, we have that Blausche. He created or he established a different way of working with these exoskeletons. And what he did is that he used an optic system that could sense the pressure that you are putting into the end of the extremity, so that he can measure and he can work well with the answer, with the feedback, so that he can provide a better response to the user. So why are we doing this? Well, a lot of people have to use these exosuits to perform daily activities, to walk, and it can be for many reasons that we are not going to focus on this. But eventually, when these users use these exoskeletons, they feel uncomfortable. I mean, they are going to start to getting tired. Also, the device is going to be a little bit invasive. So the problem here is that these devices are getting invasive into the users, and they are not so immediately with the knee movements. So now that we have already stated the problem, what are we going to do? What is our goal? Well, generally speaking, we want to implement a disturbance observer-based motion controller for the knee exoskeleton application. But when we want to focus into this subject, we have that we are going to design a 2-degree of freedom mechanism with a brushless motor to mimic knee movements. Also, simulate a perturbation observer-based brushless motor motion controller for knee exoskeleton applications. And once we have this, we can move to the third objective, which is implementing the 2 past objectives. And at the end, we are going to rectify the results to achieve the expected percentage of bioimitability. So why do we have a green light to move on with this? Well, basically, because there is an opportunity here, and the need of the implementation of motor assistance systems is very demanding from the people, because these devices are well used for the people in need, and they don't fully enjoy the preferred movement. They don't fully recover their lifestyle. So where do we want to go? What is our scope? Well, the exoskeleton is attached to the knee to assist the user so that the patients can move on properly, that they can feel relief when they are doing their daily activities like walking, using the stairs, running. And for this, it's very useful our device because it's going to have a great bioimitability of the natural movements of a human knee. Unfortunately for us, our system or device is not going to be perfect. It's going to have some delimitations. So here I'm going to list the delimitations in three categories: the input delimitations, the planned delimitations, and the output delimitations. So in the input delimitations, I have a 56 voltage power supply for the controller, which is an O-drive board. Also, the direct current or the continuous current is going to be the right one to make the system work properly. Also, the readings are going to be based on the movement of the knee, and a 5 volts power supply is going to be enough to supply or to fit the encoder. Also, the material of the prototype is going to be made of a polymer. About the plant, the couple actuators are going to be a brush DC motors, and we're going to have two brush of these motors, two of types of the motors. Also, we're going to use a Raspberry to communicate these two types of controls. The power supply is going to be portable, for the user can move on freely, and the device and the design of the device is going to be a prototype. About the output delimitations, the device is going to be intended to use only for elder people, at least at first. The response capture is going to be given in decimal values, and the motor actuators reflects in RPM. The exoskeleton is designed only for a knee joint, very important, and the exoskeleton is constrained for a 0 to 160 degrees. And move with the project schedule, we are going to have this table which shows the different activities. For example, at first we're going to grab some information regarding the composition and the well working of a 2 degrees mechanism. There we're going to design a CAD prototype, get the materials, assemble the mechanisms, and then we're going to implement the motor into the mechanisms. They're going to do some tests, and we're going to analyze and document the results. For the second part, we're going to grab some information, investigate about the perturbance observer method and the O-drive controller. Then we're going to gather some materials to make a circuit. Then we're going to integrate the circuit so that now we can start doing some tests, check the results, implement the controller, and then analyze and document the results. For the third part, and almost the last one, we're going to assemble the mechanism with the design. We're going to do some tests. We're going to make some graphics about the solution, and also we're going to analyze the results and document them. And at the end, of course, we're going to have the conclusions and the general results sections after we do some rectifications to the systems. About the theoretical framework, we are going to have several subjects, but at the first we're going to focus on the brush DC motors, for example, its component, their working, functioning, and then we're going to have the control. We're going to go with the basics as the plant, actuator, sensors, and also the haptic and the encoder systems. At the end, we have this reference matrix where we are going to gather all the references that we use, and we're going to create a relationship with all of them. For example, we can have here the title number, then we're going to have the author, then we're going to have the title, and then we're going to have the object study, which means that what the author, the reference is going to be about, and then we are going to have the method, which is the way that the authors came to a result, came to a solution. And here we continue with the reference matrix, but in this section is more focused into the design of the exoskeleton. So thank you for listening, for having the time of attending this presentation. These are only the reference, and thank you.